Welcome back, fellow curious minds, to another exciting episode of Exploring the Universe. From the official channel of Amit Ranjan. Today, we embark on a journey that has puzzled scientists for centuries: the origins of life on Earth. From the primordial soup to the complex ecosystems we see today, the story of life's beginnings is one of science's greatest adventures. Buckle up as we dive into the fascinating world of abiogenesis and evolution. Our 505 million-year-old jellyfish fossil finds show how life began and Earth transformed. Paleontologist Mr. Jean Byrne-Caron is Associate Professor of Earth Sciences at the University of Toronto. He works on jellyfish fossils that date back millions of years. We know of jellyfish today in modern oceans. Some people may have received stings because of their tentacles, which are designed to grab prey. Tentacles define this group of beings called cnidaria, which includes corals. He studies this and works as curator of invertebrate paleontology at the Royal Ontario Museum, Rome. Researching such fossils illuminates the roots of our modern biodiversity. These help us understand where we come from and how life on Earth emerged. These studies show us how groups of animals which we often take for granted, such as the jellyfish, have been around for a lot longer than human beings. We could try feeling a bit humbler about ourselves as well as more gratitude about being on this planet, where we are but small tip of a very vast existence. His research work found this on mountains in the Canadian Rockies in British Columbia. The site is called Burgess Shale, where such fossils were earlier found by Desmond Collins of the Rome. It became a World Heritage Site in the early 1980s, famous for the exceptional preservation of soft-bodied fossils. That means fossils which don't have shells or bones and typically don't get preserved. Here, the discovery of these jellyfish remnants, now called Bergosum fusiformis, brings the fossil record to a new high in terms of what can be preserved. Considering that jellyfish are 95% water, these fossils are exceptional. From the context of a Cambrian animal, these jellyfish or medusozoans are really large. Most fossils with shells are no larger than a human finger, but these are the size of a forearm and have their tentacles preserved. It is very rare to find fossils of beings which swam in that environment, but clearly, swimming was well-established behavior for many animals like Anomalocaris, a giant predator related to arthropods. Understanding that entire food web is important. Free-swimming jellyfish were a crucial part of it, eating arthropods and other organisms, controlling species and growing larger, developing a bell-shaped form. At the time, all animal life actually lived in the oceans. The origin of life itself is much older. It started with very simple cells, maybe 4 billion years ago. It took 3.5 billion years to start more complex life forms. It's only relatively recently that animals evolved during the so-called Cambrian Explosion around 541 million years ago. The group, which includes jellyfish, evolved not more than 600 million years ago, whereas life on land, especially animals, happened much later, perhaps 450 million years ago. The first animals on land were likely arthropods or species with jointed limbs like shrimps, lobsters, etc. It is only much later that vertebrates made it on land. The Burgess Shale itself gives us a glimpse of life 505 million years ago. It shows us representations of most of the modern groups of animals we know today, including ourselves. Many look quite different but share characteristics we still find. For example, in our ancestors who are much younger than jellyfish, we find a lumbar cord which becomes the vertebrae in ourselves. As these remnants indicate, a diverse community lived back then and the jellyfish was an important member of it, a fact which remained undiscovered for a long time. We are happy to be able to publish our findings of it now. One of the most interesting facts about these fossils are that these marine fossils at 250 to 300 meters elevation in these mountains, whereas in the Cambrian time, they were in the ocean at 100-meter depth. This shows us the process of plate tectonics. Part of Earth is made of plates which move against each other. At times, they collide, a process which made the Rockies, or go under continents and push up, like the Himalayas in the Indian subcontinent. We are living on a dynamic planet. The fossils we have found now on top of these mountains have a magical aspect to them. When you think about where these beings actually lived, you realize how much has changed and how landscapes have completely transformed. Conclusion. The story of life on Earth is a testament to the wonders of science and the resilience of life itself. From the humble beginnings in the primordial soup to the vast ecosystems that thrive today, our planet has witnessed an extraordinary journey. Remember, It's up to us to protect and preserve this remarkable legacy for generations to come. Thank you for joining us on this captivating journey through time. If you enjoyed this episode of Exploring the Universe, don't forget to like, subscribe, and hit that notification bell for more fascinating content. And, as always, keep asking questions and never stop exploring. Until next time, stay curious.